So in this video, we are getting started with an introduction to variables and then some examples on how we'll use those variables in our C# programming. So if you're not really familiar with the concept of variables, you can kind of think of it like this. So all applications process data. Data comes in, data is processed, and then data goes out. Data usually comes into our program from files or databases, user input. It can be temporarily put into variables that are then stored in memory of our running application. When the program ends, the data in the memory, it's reclaimed by the operating system, so that information is lost. Data is usually stored or output to files and databases. You might display it on the screen, you might send it to the printer. When using variables, you should think first about how much space a variable might take in memory, and second, how fast do I need it to be processed? So we control this by picking an appropriate data type. We can think of our simple or common types such as int, which is for integers, double for being our decimal base numbers. We also have float and decimal to store all different types of values as being different sized storage boxes. So where these smaller boxes would take up less memory and may not be as fast at being processed. So for example, a 16-bit number might not be processed as fast as adding 64-bit numbers on a 64-bit operating system. So some of these boxes may be stacked close by or together, and some may be thrown into a big heap further away. As you kind of learn to write your software and work with different types of variables, you start to really learn the nuances of kind of what I'm talking about when it comes to choosing the right data type. But let's get started by looking at some basics of some of the data types that I mentioned. So we're going to start with storing numbers. So numbers are data that we want to perform an arithmetic calculation on. So we might be multiplying something, we might be adding two numbers together. The reason I say that we want to make sure that we're performing an arithmetic calculation on it is sometimes we have numbers that we don't do that with. Like a telephone number would not be considered a number. So when we decide whether a variable should be stored as a number or not, we have to ask ourselves whether we would need to perform arithmetic operations on the number, or whether the number includes non-digit characters such as parentheses or hyphens, or are maybe alphanumeric. So numbers can be natural numbers, right? Such as, let's just say 42. Numbers that we use for counting, like whole numbers. They can be negative numbers, so we could have negative 42. They can be real numbers, such as 3.9 with some kind of fractional part. And we can have those single or double precision floating point numbers. And there's a lot of reasons why we might want to represent numbers with different types of precisions depending on the operations that we're wanting to perform and how precise our calculations need to be. So using our Hello World console application, or you're welcome to start a new console application in Visual Studio, let's look at how we can work with some of these numerical data types. So first I'm going to remove the console write line statement. So we're just here inside of the main. Now everything we type inside of the main is what is going to be executed by the compiler and then either evaluated to make sure that the statements are correct, and then if they are, run for evaluation. So we can type in our data types and take a look at some of the different ones that are available. So maybe we have, and I'm going to comment these so that we have some notes to look at as well, unsigned integers, right? These would be positive whole numbers. These also include 0. So we call these uints, right? Unsigned integer, uint. We give it a name, and then we assign it a value using equals. Now, Visual Studio is going to automatically give us a little underline. If we put our mouse over that, we can see that it's just simply a notification that says you created this variable, but you haven't actually used it anywhere. And that's to make sure that we're thinking about maybe we defined a bunch of variables and then we changed the logic of our application. We can go back and remove any variables that maybe we defined but then ended up not using. We're creating space and memory. Our application is taking up more space and memory when we have variables declared, even if we're not using them. So that's why Visual Studio gives you that notification to make sure that you're aware that you are taking up space that you're not using. So then we have just regular integers, right? Integers, whoops, comment line. This means negative numbers or positive numbers, whole numbers. And we just say int. And again, we can just store this as 23. Any number you want to put in there is fine. Whole numbers. Let's say we do a negative instead. Perfect. We also have float. Float means single precision, floating point, and we have two different notations we have to pay attention to. So first off, we call these float. So just like uint was for unsigned integers, int for integer, float for this particular data type. I give it a name. I equal it to a value, let's say 2.3, but it's not acceptable to the compiler until I also end it with a capital letter F. And so we can make a note here that F suffix makes it a float literal and is required. So if I take that off, the compiler will give me a red mark as an error and let me know that that's not acceptable. We have to have the F suffix. We can also look at double. Double means double precision, floating point. So we use the word double to identify these. And note that I don't have to make any further notation like I did with float. So there's a lot of different kind of numerical and other types of variables that we could look at. And then we'll also look at how we're going to use some of these variables in our application. But let's pause for now, and you can get some practice looking over the data types list and maybe declaring some of these and putting correct values in them so that you can see how that works in Visual Studio.